Okay, so before the end of the previous session, we noticed that I mentioned that the rate of almost of 10,000 barrels per day doesn't sound like a good fit as a well type for all these wells, and I think I spotted the error. Um, I should have used a production average instead of a production total here in this function. Let's see. Now you see that it's coming to a much reasonable value of 6,070 barrels. So the last thing that I want to do with this, it's produce a plot with this well type. So rather than create a new function, I'm going to show you how to retrofit existing functions. So this normalized plot, I'm going to start to retrofit the normalized plot so that we can also include a plot of a normalized of a well type. So I'm going to say norm data, and I'm going to put here none. So in case that if I don't pass data by default, this is going to accept the norm data. It's going to be equal to none. Then what I can do is say if norm data is different, and to do different, I do exclamation mark equal none. So if it's different to none, I'm going to basically do time equals normalized time equal, let me check just a second. I want to pass, actually what I want to pass is a well fit. I want to pass this well fit. Into the plot. So norm data is, let's call it well underscore fit is equal to none. If well underscore fit is different than none, I'm going to get the fit. And for that, I know that just going to make a bit of an assumption here, because I know that I'm going to use straight away the way the data, the time for the well 4. Okay, we'll see how to sort it out for as a generic function, and then the rate that we're going to predict, it's equal to ARBS. Sorry, someone is. So it's equal to ARBS, and we're going to give the time, and we are going to pass now the well fit that we're passing on the function, and we will use a beta, the first argument, then the initial rate, and finally the decline rate. I think we call it decline, if I'm not mistaken, or decline rate. And I'm going to add that plot to the mix by doing AX plot time rate, and label is going to be equal to my well type. So let's see if that works. So I'm going to call plot underscore well fit is equal to normalize plot, and now I can do df selected wells. If I only run this, as you can imagine, it's going to return the previous plot, but now we have the option to provide the well fit data. So I can pass well fit, boom, and now I have an error. Oh, let's see what's going on. Can multiply sequence by a non-int of float. Time. I'm not quite sure what's going on there. Don't see anything particularly wrong. If you have any idea, let me know, but I'm pretty sure. Hold on a second, let's see if these values are okay. Yes. So this rate, I'm passing the time, well fit beta, initial rate, and decline rate. Can multiply sequence by a non-int of type float. I think it's something related to the time. Oh, I see. Yes. So, right. So I'm using on the normalize on the time. I'm actually this is not time. I need to get the actual final time from the F. I need to get the final time. The final time. So I need to do a normalized data. I also need the normalized data here. Okay. So I'm going to use norm data. And norm data of well W4, and I'm going to use this time. Let's see if that works. And of course, I need to edit this to pass the norm data. Hopefully that will work. Yay, here we go. So now that's this is my well type. And so you can imagine that we have selected these wells based on certain characteristics that makes them quite similar, and that we could we want to generate a well type to predict the performance of the future wells that we haven't drilled, or potentially the performance of completions or workovers on future wells. So that's on exercise 1. And I'm going to move on to exercise 2.